Okay, we're going to start chapter 3-4 notes. This is basically going to start off exactly where we left off. This is the factor theorem, and then it says if this linear binomial, so it's linear because it has a power of 1, it's a binomial because there are two terms, which is what bi is talking about. They want to know if it is a factor of this quadratic that is a trinomial. Okay, it has three terms. Quadratic being it has the highest power of 2. Now, this is no different than what we've been doing. We can use long division or synthetic division where we're able to. And in this case, we are able to use synthetic division. So we are going to set this equal to 0 and solve for x. So x is going to equal 3. And then we're going to set up our coefficients inside of our division. For synthetic division, it goes 2, 1, none, so there are no gaps. So it goes 1, 2, and negative 3. 3 goes on the outside. We're going to drop the 1 down. 3 times 1 goes here, 3. We're going to add down the columns. 2 plus 3 is 5. Now we're going to do 3 times 5, which is 15. We're adding down, so 15 minus 3 is going to be 12. If we get a remainder, then we say this is not a factor. So since I have a remainder, I say not a factor. This is no different than what we've been doing. Okay, so let's go to the next one. Let's go to example B. If at any time you think this is moving just a little bit too fast, just ask the sub to press pause so that you can catch up. So the first thing we're going to do is set this one equal to 0. X is going to be equal to negative 4. Okay. This goes 4, 3, we're missing a term. Okay, the term that we're missing is the 0x squared. So it goes 4, 3, 2, 1, none. So now we have everything accounted for. So negative 4 goes on the outside, and all of our coefficients go on the inside. So we have 2, 8, 0, 2, 8. So what we're looking for is to see if this is a factor. If it's a factor, then our remainder will be 0. So drop our 2 down. Negative 4 times 2 gives me negative 8. 8 minus 8 is 0. 0 times negative 4 is 0. 0 plus 0 is 0. Negative 4 times 0 is 0. 2 plus 0 is 2. Negative 4 times 2 is negative 8. So 8 minus 8 is 0. Since that is a 0, we can now say, yes, this is a factor. Okay, so yes, that one is a factor. So remember, if the remainder is 0, it is a factor. If there is a remainder, then it is not a factor. All right, so moving on, we're going to go to example number 2. So if you've been skating by on factoring, you're going to really probably pay for it here. So if you have kind of been skating by, you need to come in and see me because the factoring is going to get a little harder from here on out. What we're going to do is called factor by grouping. So most of the time, what's going to work is if I group terms 1 and 2 together, and if I group terms 3 and 4 together. So what I'm looking for here, the first thing is to find something common in every term in this first one, okay? So just by looking in this first one, what I see as common is there's an x in every one of those terms in this first one. And actually not just an x squared. So I'm going to pull my x squared out. And what does that leave me with? X cubed divided by x squared is going to leave me x. 3x squared divided by x squared is going to leave me with a 3. Okay? Now, I'm going to use that same property when I look at this second one. what's common in both of those terms? Well, 4 is a factor of 12, and they both have negatives, so I can pull out a negative 4. Okay, negative 4x divided by negative 4 leaves me with a positive x. Now from here, if I take negative 12 and divide it by negative 4, a negative divided by a negative is a positive 3. All right, so I have x squared times x plus 3 minus 4 times the quantity x plus 3. Do you see these are two separate terms here? And do you see anything common in those two terms? Well, I see something common in both of those, and it is the x plus 3. So the x plus 3 is common. And just like here, when we seen that the x squared was common, we pulled it out front. Here we seen the negative 4 was common, so we pulled it out front. We're going to do the same thing. We're going to pull out the x plus 3 because it is common. Now, when we took these out front, we used parentheses to see what was left. Okay, so we put parentheses around what was left. We pulled out the x squared that was common, put the leftovers in parentheses. Here, we pulled out the negative 4, that's what was common, and put the leftovers in parentheses. Well, here, we pulled out what's common, so now we're going to put the leftovers in parentheses. The leftovers are x squared minus 4. Okay, so all we did is found what was common, pulled it out front, put the leftovers in parentheses. Find what's common, pull it out front, put the leftovers in parentheses. Again, these are common in both of those terms. They go out front, my leftovers go in parentheses. So the next thing I have to do is I have to ask myself, can I factor this any further? Well, I can. I can notice right here that this is difference of squares. Okay, so I'm just going to bring this straight down, x plus 3. And then I know that I can split this one up evenly. It's a difference of squares. So I split my x's up, put them in separate rooms so they don't fight. And then I need factors of 4 that will add or subtract to get me 0 because I do not have a middle term. So positive 2, negative 2. These are all of my factors. Okay. Now, there's a way that I can check my work. And the way that I can check my work is by getting a graphing calculator. Okay, go to my y equals, and I'm going to put in that original equation. So I'm going to put this in. So x cubed plus 3x squared minus 4x minus 12. Now, when I graph this, knowing what we know about factors and x-intercepts, I should have how many x-intercepts? 1, 2, 3. And more specifically, if I solve these for x, I should have x-intercepts at negative 3, negative 2, and positive 2, if I have done this correctly. So let's hit the graph button. There we go. So negative 3, negative 2, positive 2. Exactly what we have. Negative 3, negative 2, positive 2. This is how you're going to check your work. Okay, let's do another example. Okay, let's move down here. Most of the time, grouping the first 2 and the second 2 will almost always work. Sometimes not, but for the most of the time it will. When I look at this first one, I notice what's common in both terms, x squared. So I'm going to pull out what's common and put the leftovers back in parentheses. So x cubed divided by x squared leaves me 1x. Negative 2x squared divided by x squared leaves me negative 2. Now I'm going to look at this one. If we can pull a negative out at any time, we want to do that. And so this very first term starts with a negative. So we want to get that negative out to the front. So I know that 9 is a factor of 18. So I'm going to go ahead and pull the negative 9 out. When I do that, negative 9x divided by negative 9, so a negative divided by a negative gives me a positive, and it just leaves me with an x. Now I have 18, which is positive, divided by a negative 9, so a positive divided by a negative leaves me a negative 2. Now, when I look at this, I'm looking at these terms, so I have my first term and I have my second term. What's common? X minus 2. So just like here when we pulled out what was common, we're going to do that. We're going to pull out what's common. And where do we put the leftovers? We put the leftovers in the brackets. So x squared minus 9. Okay, we're getting pretty lucky here, and I keep getting left with difference of squares. These are both perfect squares. X squared is a perfect square, 9 is a perfect square. We drop this one down, x minus 2. Factor the next one. I'm going to split my x's up. So x and x. Factors of 9 that will add or subtract to get me 0 would be plus 3, minus 3. Okay? If I set each of these equal to 0, you're going to see that x equals 2, negative 3, and positive 3. So I can check my work again by going to my graphing calculator. In the y1, go ahead and put in our original equation. So x cubed minus 2x squared. Oops. All right, and minus 9x plus 18. Hit the graph. So I'm going to wait for my graph to come up, and hopefully we will have x-intercepts at negative 3, positive 2, positive 3. Does that match what I got? Yes, it does. So I have an x-intercept at negative 3 right here, positive 3 right here, and positive 2 right there. All right, let's do the second example here. All right, so let's look at this one. Again, we're going to group first and second terms, and then we're going to group our third and fourth term. So we're going to look here and see what's common. Again, the only thing that we see that's common in both of those is x squared. So I'm going to pull the x squared out. The leftovers go in parentheses. So 2x cubed divided by x squared is 2x. X squared divided by x squared is 1. Now, when I look here, I see that there is 4. 4 is a multiple of both 4 and 8. So let's go ahead and pull the 4 out. I don't have any negative numbers, so I don't have to worry about pulling out a negative. So 8x divided by 4 is 2x. 4 divided by 4 is 1. Again, I'm looking for the things that are common. This is common. This is common. Again, just like we pulled out what was common in the very beginning, we're going to pull out what's common the second time, which is 2x plus 1. And where do we put the leftovers? They go back in the brackets. So x squared, this is a positive 4, so plus 4. Now when we look at this, we might be thinking that this is a difference of squares, but difference means subtraction, and this is addition. All right, so this is not going to factor. If we set this equal to 0, move the 4 over, we have a negative, and a negative underneath the radical would give us I. So right now, we know that this one, if I set it equal to 0, is going to give me negative 1/2. This one is going to give me plus or minus 2i. If you don't believe me, go ahead and set that one to equal to 0. That means I'm only going to have one real root. So let's graph it and see if I'm right. All right, so we have 2x cubed plus x squared plus 8x plus 4. So if I'm, oh crap, sorry, cubed, arrow over, x squared. Oh my goodness, seriously. Plus, and there we go, plus 8x plus 4. Graph. So if I've done this correctly, this should only hit the axis one time. There it is at 1/2. Okay? All right, so let's look and see what else we have here. All right, so what we're going to do is we're going to stop there for today.